Neeraj. I am studying in second year B.Pharm in Siddhant College of Pharmacy. Today I am going to present factors affecting of solubility of drugs. So what is meant by solubility? The solubility of drug is ability to dissolve in a specific solvent. Its crucial factors in drug formulations impacting bioavailability and efficacy. The factors that affect the solubility are temperature, pH, pressure, complexation, and etc. So what is meant by solubility? Maximum amount of solute that dissolved in a solvent in a specific room temperature is called as solubility. So the factors influencing solubility of drug, the first factor is temperature. The temperature drops while you mix the solid and the solvent. The temperature will increase and the solubility of the solution is increases. The temperature stays neutral. The temperature will have minimal or insignificant effect either way. The temperature is increased when the solute and solvent are mixed. Raising the temperature will decrease solubility. Next is a pressure. The effect of pressure on the gas by the Henry's law, which states that in a very dilute solution at a constant temperature, the concentration of the dissolved gas is directly proportional to the partial pressure of gas above the solution at equilibrium. The concentration of gas is directly proportional to the solubility of coefficient and partial pressure. If the pressure increases, the solubility of the gas increases, of the solution increases. Next, presence of salt. The liberation of dissolved gases from solution with the addition of electrolyte like NaCl or non-electrolytes such as sucrose is called as salting out. The presence of salting out increases, the solubility of gas increases. In the absence of salt, the solubility does not increase. Effect of chemical reaction. By the Henry's law, that are slightly soluble in solution and do not react with solvent. The gases like hydrogen chloride, ammonia, carbon dioxide, as a result of chemical reaction between the gas and the solvent, and the chemical reactions affect on the solution and the solubility of the solution will be increased. Next is effect of foreign substances. The addition of substances to a binary system produces ternary system. If the added substance is soluble, is only one of the two components, the mutual solubility of the liquid pair decreases. The substance is soluble in both components, the mutual solubility of the liquid pair increases. Next is effect of pH. The most of the drugs are weak acids or weak bases. The solubility depends on the degree of dissociation, degree of ionization, which is depends on the pKa and pH. The pH at which the drug is then traveling in the ionic form, it behaves as a solution of drug, a strong electrolyte, and no solubility problem. Next is a common ion effect. The solubility of sparingly soluble electrolyte is decreased by the addition of second electrolyte. Means the two electrolytes are added in the same solution, the solubility will be decreased. Influence of the solvent. Like dissolved light, the polar solvent and the polar solid, the mix together and the solubility of the solution will increase. Influence of co-solvent. The combination of solvents shows better solubility. Next is nature of solute and the solvent. When two substances are similarly, they can dissolve with each other. Polar solids dissolves in polar solvents. Non-polar solids tend to dissolve in a non-polar solvent like dissolved light. When the two liquids dissolve in each other because their molecules are alike in polarity and the solubility of the solution will be increased. The effect of complexation in multi-component system. The pharmaceutical complex formulation consists of many ingredients. The apparent solubility of some solid in a liquid may be increased or decreased by the addition of substance that forms a complex which is either more or less soluble. For example, the solubility of iodine in water is increased by the addition of potassium iodide, which forms a soluble complex. And the other hand, the solubility of tetracycline is reduced when it forms the complex with calcium. The next is Effect of particle size, shape and the surfaces. If the particle size decreases, the surface area increases and the solubility also increases. Physical forms of drugs. The amorphous forms of drugs have greater aqueous solubility than the crystalline forms. Then the molecular size. Larger molecular size reduces solubility as solution by the solvent decreases. Then next is the dielectric constant. The solubility is a function of dielectric constant of polar and non-polar medium. Most often with hydrophobic drugs, the solubility decreases with increased dielectric constant. This is inversely proportional to each other. Thank you.